I'm going to be doing problem 13.14 today. So it says planet Z is 10,000 kilometers in diameter. The free fall acceleration on planet Z is 8 meters per second squared. We want to know what is the mass of planet Z and what is the free fall acceleration 10,000 kilometers above planet Z's north pole. So we're given that the diameter is 10,000 kilometers, which we can convert to 1 times 10 to the 7th meters. And we also know that the radius is 5,000 kilometers since 10,000 divided by 2. So we can change that to 5 times 10 to the 6th meters. And then we also know that g is equal to 8 meters per second squared. So the equation that we're going to want to use is little g equals big G times m over d squared. The little g is representative of the acceleration, big G is the universal gravitation constant, m is the mass of the planet, and d is the distance from the center of the planet. So what we're going to do now is start plugging in some values that we were given in the problem. So we know that g is 8. The universal gravitation constant is 6.67 times 10 to the negative 11th. M, the mass of the planet, is what we're solving for in part A. And for D, we know that we're going to want to use the radius of the planet and not the diameter because of the fact that the acceleration is taken in respect to the surface of the planet for part A. So we're going to want to use our 5 times 10 to the 6th meters that we calculated earlier squared. So now if we rearrange that, we have 8 times 5 times 10 to the 6th squared equals 6.67 times 10 to the negative 11th times the mass of the planet. And we know that if we rearrange that once again, divide everything by this constant, that's going to cross out and that will carry over. So we have 8 times 5 times 10 to the 6th squared all over 6.67 times 10 to the negative 11. And if we calculate that out, which I just paused to do, we get 2.999 times 10 to the 24th kilograms for the mass of the planet. So for part B, we're going to be able to use the same equation that we used for part A. What's changing is that now we know the value of the mass of the planet from the previous part of the problem, and we're going to have a new distance. So the distance that we should use this time is the 5,000 kilometers, which is our initial radius of the planet. And since we know that we are 10,000 kilometers above the North Pole, which is at the surface of the planet, we're going to have a total distance of 15,000 kilometers. Okay, so I just did the unit conversion from kilometers to meters, and now just like the first part of the problem, we can just start plugging things in. So we don't know g, which is what we're going to solve for. We know, like before, the universal gravitation constant, times 10 to the negative 11th. We know the mass of the planet, 2.999 times 10 to the 24th. And we divide all of this by 1.5 times 10 to the 7th squared. And then if we use a calculator, we find that the value of g is 0.888 meters per second.